Good morning and a warm welcome to all the viewers and participants joining us on Masa University Facebook page and YouTube channel. We are delighted to have you here for the webinar series hosted by the Faculty of Engineering, Built Environment and Information Technology at Masa University. I am Siti Shahira and I'm honored to be your moderator for today's sessions. Our featured speaker for today's webinar is Dr. Hanis Farha binti Jamahori. Dr. Hanis Farha serves as an academic and researcher with her current research focus on spanning critical domains including power system modeling and distributed generation in electrical engineering. Her research stems for her PhD work in photovoltaic and engineering management system. She obtained first class diploma and bachelor's degree which qualifies her to pursue fast-track PhD in electrical engineering at University Technology Malaysia UTM. She is a member of the Institute of Electrical and Electronics Engineers IEEE and is a graduated member registered with the Board of Engineers Malaysia BEM. Without further ado, I would like to welcome Dr. Hanis who will be speaking to us with topic addressing challenge in current energy grid. All right, Dr. Hanis, the floor is yours.
Assalamualaikum warahmatullahi wabarakatuh and a very good morning to all audience. And thank you so much to Dr. Siti Shaira for the introductions. Okay, so my name is Dr. Hanis Farha binti Jamahuri. So before we begin, I would like to ask the audience, okay, so in our current grid right now, we are currently moving toward the transitions from the conventional fossil fuel to the renewable energy. So can you imagine what our future grid will looks like if the fossil fuel extinction is nearly extinction? What will happen to our current electricity grid? So we should be blessed and should very thankful to our creator because we are blessed with the abundance of the renewable energy sources. We will not deplete. We have like the abundance and also we can use it multiple times compared to the fossil fuels. Okay, so in order to integrate the renewable energy into the current energy grid, we'll face a lot of challenges. So this webinar, we will discuss about addressing challenges in our current energy grid. Okay. So this is the outline of the webinar, which I will just divide into three sections. Which is the first one is to introduction to electrical energy grid system. This is basically for those who are not from electrical engineering background. So I just give a brief overview about the components, the basic components of the electrical energy grid systems. And then before we go and discuss on the challenges in the electrical energy grids, which is our future and also the current and also our future electrical grid, and how we can address these challenges into our future smart grid system. Okay, so I just begin with this one. This is just like a basic components of electrical power systems. So for those who are not from engineering background, again, I will just give a brief overview about our current electrical power system. So the basic components that we have in our electrical power grid system is generation side, transmission side, distribution side, and also the consumer. So the generation side is actually the generating system which are involved with the power plant and where all the electricity is being generated. This involved with a huge and also large power plant that can be various, and currently we are using a fossil fuel, mining, coal, mineral oil, crude oil as our main electrical resources. And after the electricity is being generated at the generation side, it will be transmitted to the transmission line. This is where when you go passing by through the highway, you can see like there is a tower there that is called a transmission tower. The transmission tower, we have all the cables there. You can see the overhead line cables which will be used to transmit the electricity from the generation side to the distribution side. So the transmission system, it acts as a medium to transmit between two sources from generation to the distributions. And after it is being transmitted, after the generation is being transmitted, it will transmit through the distribution line. This is where you can see along the road, the small road, the main road, and also how the distribution system is being connected to the substations. And currently in our in Malaysia, we use the TNBs as our main utility. So in the distribution system, what we can see is that it being stepped down because currently the transmission line will carry like a very high voltage, and this high voltage is we cannot cater high voltage on the demand, because different demand, they have like different um, voltage that they can well adapt, right? So in the distribution line, it will be stepped down, the electric voltage will be stepped down, and then before it being distributed to the consumer. So who are the consumer? We are act as a consumer. And the consumer is actually divided into three main categories, which are industry, and residential, and also commercial. The industry consumer is act like a factory, the mining factory, the large company that utilize a very high voltage compared to the commercial. The commercial building is like the university, office, schools. Okay, so the residential is like our common residential housing area, the apartments, the landed area is called as residential. And also, as you can look here in the transmission system, there is also a heavy, which is the very heavy factory that will utilize directly, will be connected directly through the transmission system. Why? Because this customer is actually, they require a very high voltage, and it cannot be connected directly to the distribution line, because in distribution line, the high voltage has been stepped down, and only the residential and also commercial, and also just like they have like the range voltage that they can cater, they can supply to the load, compared to this one. If you can see, this one directly connected to the transmission system, which means that it requires a very high voltage to be operated. Okay, so done with the introduction of basic components. So what are the main sources of energy in Malaysia? So you can see that as of 2022, it is reported by the energy, the SEDA in Malaysia, that um, Malaysian, we use like up to 40% of electric production by using a gas, natural gas. Okay, so the natural gas, you can see it is non-renewable. The natural, anything that related to heat gas, it will involve in heating. So the heat will be converted into the electricity for manufacturing, for factory, for industry consumer. So the rest of 36% is from the oil, which is the crude oil and also mineral oil. This is also a non-renewable. It will cause a pollution and also bring harm to our environments. Okay, and the oil is actually for the transportation and also manufacturing. 21% of our main sources of energy in Malaysia come from coal. It is also a non-renewable. It is used to convert the coal from the mining, and also from the from the burning, and convert the process into the electricity. The rest is just like the rest, the renewable energy, the biomass, which comes from the crops, woods, food waste, garbage, and sewage, is also like only 2%. And the rest of the renewable, like solar PV, wind turbine, geothermal, hydropower, is just contributed to 0.78% to our Malaysia. So you can see like the non-renewable is being used as the main electric sources in Malaysia. And the non-renewable sources on the other side is bring harms to our environments. That's why we have to transmit, and also we have to change from the conventional using this kind of gas or coal to the renewable energy. Okay. So what are the challenges that we face in our current electrical energy grid? These are the factors. Okay, you can see there are so many challenges that we can see here. The first one is aging infrastructure. The infrastructure that has been used in Malaysia is aging, is very old. And why? Because you know that it requires upgrade, because it's been implemented back then in a few years back then, and then it's already aging. We have to upgrade our infrastructure, and to upgrade the infrastructure, it requires cost, money. Okay, so the second one is we want to integrate the intermittent renewable energy integration. So we know that renewable energy sources like wind and also solar PV, it is fully dependent on weather condition and also geographical factor. So in order to integrate into our current electrical grids, we have to consider few aspects. There are more aspects that we have to consider, because what if we install the PV at the wrong location? and there is no solar power available. Like no solar, why you need to install the PV? And also same goes to wind turbine. You install PV at the wrong place and there is no wind available, so the energy will be wasted. The cost also will be wasted. Okay, the next one is the energy transition and also policy framework. This one related to government policy on, I think the Malaysian, the TNB and the government, they have like implement so much and upgrade the policy framework just to transit from our current to the future grid. What else? Energy efficiency. So how much energy that if we integrate into our system, how much we can actually make use of this energy, how much the energy will be wasted. That these are the questions and the challenges that we need to cater. The next one is capacity and demand imbalance, which means that we are supplying as a supplier, the electrical supplier, they supply to the load. So what if the demand and also the generation is not balanced? The imbalance, which means that you supply to the load, but the demand is not matched, which means you produce the over generation and also insufficient of the agent energy generation, so it will be wasted. So this wasted, it also lead to the cost, like total loss, and also it requires like more transition, and then you need to upgrade more, you need to invest more, it is a total loss. Okay, so the grid reliability. So what are the grid reliability? In order to integrate something else, in order you want to, because we have our conventional electricity grid, and then in order for you to include something, to add something into that grid, it requires something like you have to know how much we can fully trust these new sources, what is the reliability of these sources. For example, the PV, where can you integrate the PV in the distribution side or in the transmission side? So these are the things that we have to cater. And currently we are moving toward the electrical vehicle, like the Tesla, the hybrid one, and then they just want to like reduce the dependency on using the conventional oil, that we don't have to refuel, so we just have to charge our uh, vehicle. But then in order to adopt this electrical vehicle into our system, it also requires like good electricity, because you need to charge your vehicle. Okay, these are the challenges we compile into one, what we will call as the energy trilemma. Okay, the energy trilemma. What are the energy trilemma? Okay, the energy trilemma is actually defined as the balancing. We want to balance the trade-off between three major energy goals, which are the energy security, environmental sustainability, and also economic competitiveness. Okay, this is all, they have their own classification, and also what are the impacts on the environments, what are the impacts on the economics in terms of money. Anything that we want to integrate into the system requires money, and money is the things that all country will take very seriously, because money will like you want to deliver something and you have to invest into that system, but how strong is the system can work for you, how strong can the system will give feedback to you. Okay, so the physical availability of energy sources and also the diversification is also one of the dilemma that we have to cater. And all these three items, the three lemma that we're facing right now, is all related to the energy prices, the infrastructure costs, and also the energy conservation, energy efficiency, and also clean and carbon. Whatever we do, whatever we want to integrate into our system, we have to make sure that um, of course we want our system to be reliable, we want our system to work very good, but then we don't want to invest so much money so that it will not be wasted. Okay, so the next one is um, developing our future grid. So are we ready to develop the future grid system? Okay, as a leading Malaysian utility, which is TNB. Okay, TNB on the other side is they want to integrate, they want to create advanced transmission and distribution grid that can support the country's energy transition goals to consumer. Okay, why they are doing this? Because they aim to achieve net zero emissions by 2050. Okay, we're just like 2050 to 2024. It's just like how many years? So in line with this, Malaysia needs to we need to implement something that can help to reduce all the emission, all the carbon emission by 2050. So to emit increasing energy demand, and also we want to integrate upcoming renewable energy in the efficient manner. So the TNB has been focused on developing a smart grid network that is reliable and also flexible to meet the uncertainties of the future. Okay, how can we address? Also, we talk about the challenges that we face right now in our electricity grid. So, what are the ways to address these challenges? And the interest, as you see here, the interest in distributed generation, what we call as DG, has emerged because by the, I mentioned before, increase of the fossil fuel prices, the concern on climate changes, and also global warming issue. Okay, so what are the DG? The DG is a source, is the additional source that will be integrated into the system. So we want to add another source by not by fully utilizing on based on the TNP, based on the generation side. We don't want to use basically 100% fully utilized from the generation side. And also that's why we want to invest something. So we integrate the DG. So the DG is additional sources, and normally the DG it is some the DG is, we can see like this, the renewable energy here, the wind turbine, the PV, geothermal, hydropower is some examples of the distributed generation. So normally the DG will be connected close to the load. And the load that I mentioned before, the residential, commercial, and also um, what? Residential, commercial, and also industrial. Okay. So you know that we have like few types of renewable energy, but currently that gain much more attention right now is solar PV. We can see that solar PV has been implement, and solar PV, the large scale solar PV, and even the housing area, they also install a solar PV. So solar PV energy has evolved rapidly in the recent past. We can see it here because it's gaining more attention worldwide and being utilized as one of the alternative to replace the conventional. Why PV? But now we know that PV is highly unpredictable, highly inconsistent because of the it is fully dependent on the geographical and also weather conditions. So in order for us to integrate these kinds of renewable energy, all flexibility options, including the interconnections, the demand side response, the flexible generation and storage, need to be well developed in order to meet these challenges. Okay, so this is our conventional electrical grid scenarios. As you can see here, just like I mentioned before, we only comes from the generation side to transmission side, step down to the distribution side before we deliver to the load. The load here, and also you can see that the direction for the electricity is unidirectional. We can just like pass through from the generation side to the end user. So the emerging electric grid scenario will involve with a large scale of renewable energy. You can see here there is a local storage. It's not only dependent on the just not dependent on the generation side only. Okay, so I just go through these slides. I will just like explain this slide in more details in the next slide. So we move to the next slide. Similarly, this is our current grid system. From the power station directly to the consumer side. As you can see here, this is our current grid. And also we want to address these challenges in our current grid. So what are we going to do? So we are going to move to the future smart grid. Okay. So for the future smart grid, you can see here the first one what we can do is to integrate the large RE integrations. So we will involve with high penetration of RE as the main sources in order for us to replace the conventional fossil fuel sources. Okay, the second one is smart meter. You can see here the smart meter can be installed near the loads. It can be installed near the anything that requires the smart meter. We can just like monitor our electrical consumption every second remotely. We can eliminate the need for manual meter because previously you know that the TNB guy there's just like during our childhood, right, there is I think until today also there is someone that can come to your house and then they will just read the meter manually and print out the bills. So this is how we want to move from that conventional, it is a waste, right? So we just want to move this and then implement the smart meter, so you can just read your and monitor your electric consumptions on instantly and remotely. Okay, the third one is sensor. Sorry. Okay, the third one is sensor. So the sensor will be placed in all, it can be placed like in every sections of the electrical grid. So what are the sensor do? So we adding sensor into the system, we can have for the real time data collecting and also monitoring. It is just like you can just monitor, you don't need to go down to the site and then monitor to read to get the data collection, to get the data monitoring. So we save a lot of energy and also we save a lot of money. So the fourth one is two-way communication. For the means that two-way communication, unlike the sensor, it only works to collect data and monitor the data. But if we implement the two-way communication, they will be like a system operator. Okay, you see that the two-way communication will allow the utility operator to monitor the grid condition in real time and remotely. They can also control the grid performance, which means that you add the sensor and you add the two-way communication, so it can just like you sit in your office and then just monitor the performance of the grid remotely, and by using this uh, wireless and two-ways communication. Okay, the next one is energy storage. The energy storage system can be added and also can be integrated together with the renewable energy. Here you can see here we can integrate into this one. So why do we need the energy storage for the renewable energy? Because during you know that during a very like a sunny day, sometimes the PV can produce over generation, so the excess energy that has been generated can be stored into the energy storage and it can be used later when needed, especially at night when there is no sun and you want to like save your electricity bill, you don't want to consume so much electricity at home, so you fully utilize the electricity from the battery that has been stored during the day from the excess of PV, of excess of wind turbine. Okay, and also at home you can just like, I think this one similar concept, you can add the solar PV at your rooftop and then you can just store the excess energy to the uh, battery. Okay, the next one I mentioned before, the electric vehicle. So the transition to electric vehicle will drive innovation in battery technologies. So it also like can have like we implement the charging infrastructure, which lead to technology advancement and also economic growth opportunity. And what else? Anything else? Okay, so real-time electricity price. So the real-time electricity price here is can be monitored by the utility side and also can be monitored by the consumer side, which means we want to provide a win-win situation between two parties. We don't want just like a give benefit to one side party, right? So what we can do is real-time pricing will reflect the actual cost of producing electricity at any given moment. So including like the factor, the increase of the fossil fuel prices, the increase of the oil prices, the transmission constraint, and also the demand and supply dynamics. And finally, I think, okay, finally, we are going to invest in a smart home. So what are the smart home? You know, in a smart home currently right now, anything is just on your fingertip. So what you need to do is to just install, you can install everything here that I mentioned here in your home. So that's what we can have a smart home. So smart home will offer like a devices that you can install in your home to monitor everything inside your home without your presence. So it will offer a great control and also automation of the household appliances inside your homes, and also it can offer provide comfort and also convenience to the owner of the house, right? Mm, I think that's all for the future smart grid. And yeah, so this is so that's it. I think I have finished my I finished everything.
Okay,
So
thank you. Okay.
okay.
Okay. Thank you, Dr. Hanis, for your insightful presentation. Now it's time for our question and answer. So we have received a questions from our engaged audience. So let's start with first question. What are the potential economic implications of transitioning to a renewable energy-based grid, both in terms of cost and benefits?
Can you repeat that question again, Dr. Siti Shahira?
Okay, sorry. Okay, the question is, what are the potential economic implications of transitioning to a renewable energy-based grid, both in terms of cost and benefits?
Oh, so benefits that we want to transit from the conventional to the renewable energy, right? Okay,
Yes.
so for the long term, over the long term investment, the renewable energy technologies have the potential to reduce electricity generation costs. It can help in terms of to reduce the electricity generation costs compared to fossil fuel. So once this system is installed in our current system, it can have like the solar power and also wind turbine facilities. They have sometimes I think because we have like this has been like invest too much, so the cost is not a very like major issues because we can have like low operating costs. Since why we can say that this renewable system does not have like a very high maintenance cost, because it does not require the fuel, it does not require any terms of fossil fuels. So it can have like minimal operating costs. It can also have like minimal maintenance costs. Okay, that's
Okay, that's all the question that we received. Okay, so now thank you for the clear explanation by Dr. Hanis. As we conclude today's session, I want to express our gratitude for your insightful presentations on the addressing challenge in current energy grid. So your expertise has certainly added value to our understanding of this important topic. On behalf of Masa University, I extend sincere thanks to all the participants for joining us today. Hopefully, the presentation was beneficial for everyone. For all audience and viewers, we invite you to explore more about our programs, especially in the Faculty of Engineering, Built Environment and IT, and join us on our open day. Details can be found on our website. Once again, thank you, Dr. Hanis, for your time and engaging sessions. Goodbye, everyone, and we look forward to having you with us again in our future webinar sessions. Thank you.
thank you.